Hey guys, hope you're having a good evening. Today we're going to look at some graphs of rational functions, and we're going to be looking at their asymptotes as well. So we're going to start off with the parent function. So this is the parent function for a rational function. Please memorize this function. Okay, so the first thing we're going to do is we're going to go ahead and determine the asymptote. So remember, to determine the asymptote, aka specifically the vertical asymptote, remember we take the denominator, which in this case is x, and we set it equal to 0. That is going to be our vertical asymptote. Okay, so it says in the directions that use a colored pencil to draw your asymptote. So we know we have an asymptote at x equals 0. So x equals 0 right here. And it says to use a dotted or dashed line. So that's going to be, I know it doesn't come up very clear here, but this is a red dashed line. Okay? So we have a vertical asymptote at x equals 0. So remember, there's a strict or a good relationship between the vertical asymptote and the domain. And that tells us, the vertical asymptote tells us that the domain cannot be 0. 0 is not in the domain. Remember that this means all real numbers except x cannot be 0. Okay, so now let's take a look at the horizontal asymptote. So we're going to have to use our rules. So we look at the degree of the numerator, which is 0, the degree of the denominator, which is 1, and since the 0 is less than 1, our horizontal asymptote is y equals 0. If you don't remember those rules, go back to your video notes and review them. Okay, so we have a horizontal asymptote at y equals 0. So we haven't done anything new yet, okay, except for the fact that this is the parent function. Okay, so let's go ahead and graph it. Now, it does say to use your graphing calculator to help you, okay, sketch the graph, which you can do. But what I'm going to do is I'm going to choose some numbers to the left of 0, and I'm going to choose some numbers to the right of 0. So let's start off with -1. Okay, so if I plug -1 in, I'm going to have, if I choose -1 as an input, so 1 divided by -1 is -1. Okay, so we have a point at -1, -1. Okay, let's try -2. So if I plug a -2 in, we have 1 over -2, which is -1/2. So -2, -1/2. Now, let's try a point that's closer to 0, between 0 and -1. Let's try -1/2. So if I plug in a -1/2 here, I'm going to have 1, let me do it up here, divided by -1/2. Okay, and if you plug that into your calculator, you're going to get -2. So at -1/2 we go down 2. Alright, let's go ahead and draw in our graph. So we start along one of the asymptotes, curve through the 3 points, and then along the other asymptote. Okay, let's do the other side. So let's choose 1, 2, and 3. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. And let's choose a half instead of 3. So we're going to have 1 divided by 1/2. And if you put that in your calculator, you're going to get 2. All right. So let's plot those points. 1, 1, 2, 1/2, 1/2, 2. And there's your graph. Now for range. Now range is going to be something new. Remember that range goes from the lowest to the highest. Okay? So we could write this as an inequality. Or we could write it like this new way. Notice that our range goes infinitely down and infinitely up. So it's going to be all real numbers except what? 0. Because there's a horizontal asymptote here and the graph does not cross it. So we could say y cannot be 0. So all real numbers except y cannot be 0. Why? Because there is a horizontal asymptote there. Okay? Right. Let's see. Let's go to the back. These are all pretty simple. So let's go ahead and go down here to the graphs. It says now use what you have learned to write the equation for each graph below. Check each of your equations on a graphing calculator. Make sure that your equation creates the correct graph. Okay, let's start off with A. Okay, so right off the bat, the first thing I'm going to do is I'm going to look for my vertical asymptote. Okay, so my vertical asymptote is x equals -3. X equals -3. Okay, so once we have that, we know that x cannot be -3. So we can write the denominator as x plus 3. X plus 3. Because x cannot be -3. -3 plus 3 is 0, and we cannot divide by 0. Okay? Next thing, horizontal asymptote. Right here. This one's at y equals 2. So that's for the vertical. Y equals 2 is for the horizontal. Sorry about that. Okay, so that means that it's not y equals 0, so the degree of the numerator is not less than the degree of the denominator. It's not none, so the degree of the numerator is not bigger than the degree of the denominator. So that means the degrees must be the same. So the degree of the denominator is 1, so the degree of the numerator is also going to be 1. 1, 1. Okay, so how do we get the 2? Well, remember, it's going to be A over B. So it's going to be 2 over 1. And 2 divided by 1 is 2. So this equation right here is going to give us this graph right here. Alright guys, let's take a look at another problem. Let's look at letter F. Okay, so starting off with our vertical asymptote, we have x equals 3. Okay, so 3 cannot be part of the domain. So we're going to have x minus 3, because 3 cannot be in the domain. So 3 minus 3 is 0. Okay. Next, the horizontal asymptote is y equals 0. Remember what that means? That means that the degree of the numerator is less than the degree of the denominator. So since it's a 1, that means there's going to be no letter up here. It's going to be a number. Okay? So how do we figure out what that number is? Well, you go to the center point, you go over 1 unit, and then you count up to the graph. So it's 1 unit up. That is going to be our A value, 1. And so that's going to be our equation for this one. Okay? So anyway, I hope you're having a good evening. I know that some of us may struggle through this tomorrow. Make sure you come and ask me for some help if you need help. Have a good evening. See you tomorrow.